Hi viewers, this is Dr. Jana and you are watching video with me on digital logic design. The digital logic design, the second unit will be going for this Boolean algebra. In this Boolean algebra, or we call it as the switching algebra, sometimes we call it as the switching algebra. This is used to analyze digital gates and the different circuits. It is logical to perform a mathematical operations on binary numbers like 0 and 1. This Boolean algebra, it contains basic operations. What are the basic operations? You see, and, or, not. These are all called the basic operations. Okay, I'll show you all the things. What are the basic operations? You can clearly see it here. See, while I am going for here. So while I am going for especially here, you can go for an AND operation. So the AND operation looks like this. It will take some two input here like this. What are the input and it will come from output here. Okay. So AND gate, right? Similarly, for the OR operation, it will also look like this, right? So we will be giving some input here, two input, and it will be taking some output here. Similarly, we are having NOT operation also. We are having a NOT operation here. Right? Okay. So we will be having their operation and here to show that. Okay, what that means, whatever the value in the NOT operation, just you put it here. Whatever the value you are putting it here, the inverse of that one, it will come here at the end, right? So these are the things what will be doing here in your, so don't say it. No. Then we already studied the 9 properties or the 9 laws, whatever you say, the 9 laws of the switching algebra or this Boolean algebra, right? So here the basic operations will be AND, OR, and NOT. Three AND, OR, NOT. These are three basic operations, and the AND is represented by a dot, and the OR is represented by a plus sign, right? So then you are come to not anyway. The university itself is not. Usually that is not. We are not concerned about that one. So in the law number 1 or the property number 1, this we call it as the annulment law. Annulment law means, so I told you that in the switching algebra or the Boolean algebra, we'll be using variable as well as the numbers, digital numbers. What are the variables? A, here is the variable. 0 and 1 is the binary numbers. So telling if a variable, what is the variable? A variable is ANDed with 0. That means A dot 0, it will be 0. The variable A is ORed, you see, ORed with 1, it becomes 1. What is the meaning of that one? Say, for example, you take A is equal to 1. 1 into 0, it also becomes 0. If A is equal to 0, 0 into 0 also is equal to 0. Right? That means you take any value of A, this value only it is taking. And multiplying with 0, output will be 0. Similarly, A plus 1. You can say, sir, A plus 1, it should be A now. How it will become? How will not become 1? How will become 1? That I will show you. Suppose A is equal to 0. 0 plus 1, it is 1. In Boolean algebra, if A is equal to 1 also, 1 plus 1 is equal to 1. 1 means yes, yes, both answer is also yes. Got it now? So in this way, this annulment law, A into 0 is equal to 0, A plus 1 is equal to 1, not A. Then we go for the identity law. In the identity law, say, you see it here, we are using the OR value, or value with 0. That means A plus 0, it becomes A, and ANDed value with 1, A into 1, it also becomes A. A plus 0 is equal to A into 1 is equal to also A. Then idempotent law, what is telling? Then A plus A is equal to A. A means S plus A is equal to S. A plus S plus S. That means 1 plus 1 is equal to 1. Here, binary addition is different. Binary 1 plus 1 is equal to 1, 0. But here, Boolean algebra, A plus A is equal to A into A is also A. And in this complement law, what is telling? A plus complement of A. Suppose A is equal to 1. What is the complement of A? It will be 0. So 1 plus 0 is equal to 1. Suppose A is equal to 0. 0 plus complement. So in the both the cases, whatever the value of, because A is only binary number, you take 0 and 1, you cannot take any other things. So A plus complement of A, whatever the value of A you take, the answer will be 1. Why? Because whatever the value you take A, the opposite value will be in transpose A for complement of A. At least any value you take it, 1 will be there. If you are taking 0, it will be 1. You are taking 1, it will be 0. So in addition, when at least 1 is there, the answer will be 1. Right? Then while we are going for this A multiplied with the complement of A, here at least one value 0 will be there. When 0 with multiplied with anything, it will be answer will be 0. Then double negation, then complement of A is equal to A itself. That is there, you can understand. Similarly, commutative A plus B is equal to B plus A in OR gate, and get A into B is equal to B into A, right? Then association law, you know, A plus in braces B plus C, which is equal to A plus B in braces plus C. Similarly, the case for this the AND gate also, A into B into C is equal to A into B into C. Distributive, A into B plus C, which is equal to first operate A into B in braces plus A into C in braces, right? Similarly, while you are going for multiplication up to A plus B into A plus B, it will be A into A. See, A into A is equal to, again it is equal to A. Okay. So like that you can multiply, it will be A plus BC. Remember this thing. It will be A plus BC. Simplify, you can get finally A plus B into A plus C, which is equal to A plus BC. Clear? Are you getting it? So fine. Then this is the most important law. This we call it the absorption law. 9 number of laws are there. We call it as the absorption law. What is this absorption law? A into A plus B, which is equal to A. You get it now. Similarly, A plus AB, A plus AB, which is equal to also A. Clear? Are you getting me? This AB, when A multiplied with A plus B, that is also A. When A is added with A into B, that is also A. Similarly, A plus complement of A into B is equal to A plus B. A into complement of A plus B, that is A. So these are the rules we know. And another rule under law we call the Demorgan law. That means complement of A into B, which is equal to complement of A plus complement of B. That is there. Similarly, complement of A plus B, which is equal to complement of A into complement of B. Okay. So these are the things. And we were talking about the minimization of Boolean functions. What is the meaning of that one? Say, for example, we say a function is given f is equal to uh, complement of A, complement of X, complement of Y into Z plus complement of X into Y into Z plus X into complement of Y. So this is the functions. So can we minimize? Because you can see there are how many AND gates are there? 1, 2, here 1, 2, 4, here 5, 5 AND gates, and here 2 OR gates. You can see here. Uh, if you see it here, here 1, 2, 3, and get or get are given it here. Okay, so you minimize all things. Now he's telling the same function can be minimized to like this. How it will be done like this? You see, I'll solve this equation in front of you. Okay, x dash y dash z. Okay, let us go for that one. Okay, now let us see. So I take, yeah, I take this function. Okay, yes, this function I'll solve and show you. Right. Say what is our function? Initially, our function here, I write it here. So select it, this one. Yeah. Now I am writing f capital F which is equal to complement of x into complement of y into z plus, can you see it here? Then yeah, the thickness you can increase while you are going for this thing. The size you make it a little thicker, make this one, no problem. So complement of x, complement y into z. This equation I'm solving. Then complement of x, then y into z plus x into, sorry, x into complement of y, x into this part you can erase it. This mistake it has done, right? So is it clear? Now you see in this complement of x is here, complement x is also here. Z is here, Z is also here. If I take complement of x and z common, then it will be complement of y plus y. Clear? Plus x into complement of y. You know? Then y plus complement of y. What is the value of that one? Y plus complement of y is equal to 1. We know that one. Which rule? Check it. What is the rule you are following? Y plus complement of y, which is equal to 1. That is the law number 4, or the rule number 4. A plus complement of A is equal to 1. We know it. Get it? The same thing I am applying it here. So this y, y plus complement, this is equal to 1. This is equal to 1. So 1 into something, that becomes the same thing, which is equal to complement of x into z plus x into complement of y. So this is not the things, right? You got it now? That means all these functions, what you have given it here, it is minimized to these two functions. Okay, that is the same thing. We are going for this minimization technique. In the minimization technique, so now we could understand how we are going for the minimization of that thing. Okay, now let us see the same thing I am trying to implement here also. You see it here. Now, if you represent by a circuit here by the gates x, y, z are the three input. Here x is there, y is equal to there, z is equal to there. The first one, complement of x. For complement of x, that means one not get, I have to put it here. That is the complement of x, it is coming here. Then complement of y, y is here and it is passed and not get. So complement of y. Then z, z here also, and we are putting a z. So all the things that are ANDed. So we in the AND gate we get it here. Similarly, we can get complement of x, y into z. This is another AND gate. Again, I am going for x into complement of y. This is another AND gate. So three AND gates, we are passing through another OR gate. We get the output, that is F2. You got it now? So now, while we are going for the minimization of these Boolean functions, the same thing it is done as x into complement of y plus complement of x into z. Complement of x into z. So if you see in the first circuit, we are having at least minimum 3, 4, 5, 6 we are using, but here the number of gates is reduced. 1, 2, 3, 4. We are able to reduce all the things. Get it now? So 3, 4, 5, 6 here, 2, 3, 4. Okay. So we will be able to reduce all the things. So this is the minimization of Boolean functions that we can do it here. Then, so for this minimizing, using these algebraic manipulations, we have to remember certain important things. What are they? First thing you see it here, a plus complement of a, which is equal to 1. That you have to remember. And a plus complement of a into b, that it will become a plus b. Okay. Similarly, a plus ab, which becomes a. Right. So these are the things to remember. Now we are going for one example. Let us take. So minimize the following Boolean functions using the algebraic manipulations. Okay, using the algebra, you can minimize using the kernel map and you can use the manu. So now we are learning how to minimize using this algebraic function. Then we'll go for this kernel map. So our function was, what are that? A, B, C dash. You see here, A, B, C dash. That means complement of C, complement of D, A, B, C, complement of C, complement D. So A, B, complement of C, if I take it common, from these two terms, it is common, then it will be D, complement of D plus B. Same thing it is done here. A, B, complement of C, when taking common, then it is complement of D plus D. Remaining will be there. The last two term also, you see here, A, B, C, yeah, we check it here. A, C, D, B, B dash. A, C, D, last one. A, C, D common here, A, C, D common here, A, C, D, B plus B dash. Similar case also, you are getting it there, right? So then D plus D dash will be 1. D plus D, according to the property, we can use D plus D dash is equal to 1. So AB complement of C into 1, it will be same thing. Here also it will be the same thing. Now the entire it is reduced to this one. What is that? AB is complement of C, or I can say ABC dash, AB dash C dash D plus ACD, and like this. You got it now? Now this last two term, if ACD plus ACD dash is there, or complement of D there. If I take AC common, then D plus complement of D. D plus complement of D is equal to again 1. Then it reduced to AC. That now these are things available with you. Then here, if you take common here AB complement of C plus AC. Here I take A common, it become A into B complement of C plus C. Okay. Then only one term, this is available here. So then if you take a common here, B C B complement of C plus C, which is equal to B plus C, it is according to the property number 2, it is there. So it becomes, and if you expand these things, it becomes AB plus AC plus this one. Get it now? Now, are you getting me this thing? Now we are going for uh, so again using some property, this also we can minimize to these things. Finally, it is coming AB plus AC plus AD. You get it now? Now, what are the minimizing function we are giving? The entire thing it is minimized to this one. It is minimized to this one. So now you can understand these are little complicated because you have to remember all this property and you have to apply all this property and you have to minimize. You understand in the last two we are faced a problem. It's because some rule you have to apply and you have to minimize all things. This thing also it can be done or minimized using the Karnaugh map or the K map. Okay. So in this K map, what we do, sir? We represent all this variable 2 here in this below this one AB and 2 above this is equal to CD. Okay, and they are represented the gray value I already told you 0 1. Here it is 2 and here it is the 2 and 3, it is just swapped while we are going for the column. Similarly, while we are going for the rows, the third and fourth also they are swapped. That means what is the value, it should be here, this is coming here and this one. So this gray value you can take it here in this manner, like that, like that. Already I explained all things in the classroom. So this you can take it like this, the gray value. You got it now? Now in the K map we'll be studying because now I am giving a solution. You cannot understand these things here. So using the Karnaugh map also the same thing is reduced here and it is done very easily. That means whatever the rule you are applying to reduce to this one, how easily it can be done here. So we can make it 2 by 1 or 4 by 1 or 2 by 2 or by 4 by 4, just like square, like that we can make it here. You got it now? Now, how you do all things, that I'll see. See, we have different colors here. One you can see in the red color here, one is in the green color here, one you can see the blue color here, one is the violet color here, all the things are there. Okay. And there, what are the, see, while I am going for the green color is only this and these two blocks is there. Here, what is the common? What is the common? Common is AB. AB is the common. Is there any common here? Yeah. The common here is only C dash. Are you getting me? Are you getting me? So in this way, you can also do all the things here. Your figures highlight the parameter. The green. First, it is going for the green. Okay. So it becomes sorry. First it is going for the green color. The green color is not here. Yeah, it is only AB. Then while you are coming the red color, red is, this is the thing, it is the red color. Can you see here? So in these two, what is common? So if you see this one is common. What is one? One is equal to D. So in these two, what is common? This one is column. That is equal to A. That means it is equal to AD. Okay. So in the four square, the red, in the four square here. Okay, you got it there. One. The blue color here you can see here. What is the common here? Here, this one is common. This one means it is C, because here this 1, 0, they are not common. 1 and 1 here common, so it is C. Here, what is common? Here it is A only common, so we are writing AC. So this becomes AD, this become clear. But if you take the green color is the entire 4. You taking this one. That means here, what is the common in 4? No common is there. But here only 1 is available. That means only AB will be there. Okay. Then what we do? Just add up all the things. That is AB plus AD plus AC. So minimized Boolean expression is AB plus AC plus AD. So what we have done using this Boolean function, the same thing also we are able to do using this thing. Okay. So this is all about today's class. If you like this, I'll see that how many people are subscribing. Based on that, I'll take the second class online. Sorry. Thank you. Thank you for watching this video. Have a good day.